Kolbes Electrolysis. So what is electrolysis exactly? Electrolysis is the composition of ionic compounds with the help of electrical energy. So why do we use Kolbes electrolysis? Kolbes electrolysis helps us in providing symmetrical alkane dimers. So here we need to understand that Kolbes electrolysis not only provides symmetrical but also unsymmetrical dimers. Yeah. So here electrolyte that we use is basically salt of carboxylic acid of sodium and potassium. Sir Hermann Kolbe used originally platinum electrodes, but we can use any kind of electrode. In many textbooks you might have found that electrolyte they provide is basically of sodium acetate, but it is not necessary only sodium acetate is taken. What is sodium acetate? Sodium acetate is CH3COO Na. So it is not necessary to take only that. You can take another carboxylic acid salts of Na and K+. So let us check. RCOO Na is taken as electrolyte. So in electrolyte it is diluted, that is presence of H2O is also there. It is necessary for the reactions at cathode. So first of all let us understand the reactions at anode. What do we get there? We get dimer of alkane. And what do we get at cathode? We get NaOH, which helps in making the solution alkaline. So let us see exactly what are the reactions which occurs at anode side. So let us see. At anode, as we know, we have to take the carboxylic acid salts of Na and K plus, Na or K plus. So ROH Na is broken down into RCOO minus and Na plus. So from RCOO minus, here a electron is liberated from COO minus, and finally the bond breaking between R and C is radically bond breaking. Each of their electron is passed on to their own atoms. So the COO minus, the minus one extra electron liberates out, which is helpful at cathode side. So as you can see that R radical is provided, which dimerizes to RR, and the COO minus finally after the liberating of extra electron it gets converted into carbon dioxide, which is liberated at anode side, and it would be further used in further reactions. So you have to note that we cannot use 3-degree compounds of R. Why? Because using 3-degree of compounds of R, you will not get RR dimer. You will instead get esters. So only you can use methyl 1-degree and 2-degree elements at anode side. So let us say what are the reactions occurring at cathode side. So at cathode side, the Na plus which was liberated from COO Na, that Na plus with the help of H2O breaks down and gets converted into NaOH and H plus. OH minus of H2O reacts with Na plus of Na plus only. So finally we can get NaOH and this H plus. The electrons from COO minus gets attaches with the H plus and it makes H dimer, that is hydrogen gas. Hydrogen gas is liberated at cathode side. So with the help of NaOH from cathode and CO2 from anode, it gets converted into sodium bicarbonate. So what is the help of sodium bicarbonate? Sodium bicarbonate is basic, so it converts the solution into alkaline or basic, that is the pH increases gradually upon the processing of reactions. So let us summarize the whole electrolysis. First of all, let us throw a beaker, a big beaker. So upon throwing a beaker, there is, after taking a beaker, we put electrolytes in the beaker and cathodes. We basically prepare the setup and provide DC current to it. Yeah, you cannot take AC current. So we take DC current and we put in the electrolytes of RCOONA, and as I said, that H2O is also present, that is, it is diluted. So the RCOONA will break down into RCOO minus and Na plus, and this COO minus, the minus extra electron will liberate out, and COO minus will become CO2 and R will dimerize and will convert it into RR. So these are the reactions which occur at anode side. So this CO2 will be further useful. So now let us see what happens at cathode side. So you can see the Na plus, and with the help of H2O, they both reacts and becomes NaOH and H2O gas. So this NaOH and the CO2 from cathode side, they both reacts and makes NaHCO3, that is sodium bicarbonate. So how can we use this sodium bicarbonate? This sodium bicarbonate can be used as sodium bicarbonate test. How? We use it to determine, that is to differentiate between phenol and benzylic acid. And also, because of this NaOHCO3, which is basic, due to this the solution slowly turns into alkaline. So let us see, as we have actually learned, we know that this NaOHCO3, when it reacts with phenol, it provides us nothing. But when it is reacted with benzoic acid, what do we get? We get H2O and what? CO2 gas. Yeah, the bubble is formed. So that's how we use NaOHCO3 test. And that's all about